Hello student, from nuclear physics we are discussing about the basic properties of a nucleus. Friends, in this lecture we have to see what is a packing fraction. In previous lecture we discussed about the mass defect and binding energy. Mass defect is the difference between the actual mass of a nucleus and atomic mass number. Okay, and therefore the mass defect can be represented as ZMP plus A minus ZMN minus capital A, or simply we can represent capital M, where Z is a atomic number, MP is a mass of a proton, A minus Z represent mass of a neutron, Mn is a mass of a neutron. Okay, so the difference between the actual mass of a nucleus to atomic mass of a nucleus is mass defect. Binding energy is the energy required to separate the nucleon from nucleus. Nucleon means protons and neutrons, or simply we can say that binding energy is energy required to bind the nucleon in a nucleus. In this lecture, we have to see what is packing fraction. Packing fraction is one of the basic property of a nucleus. After attending this lecture, student will be understand about the basic properties of a nucleus, that is packing fraction. So packing fraction is the ratio of mass defect and a mass number, or simply we can say that the ratio of mass defect and a mass number is known as a packing fraction, and therefore F is equal to delta M divided by A, where delta M represent mass defect and A represent atomic mass or mass number. Therefore we can write the packing fraction F is equal to actual mass minus mass number divided by mass number, because the mass defect delta M is the actual mass minus mass number. Now packing fraction is a very small quantity, and therefore it is expressed in a part per 10 raised to 4, and therefore the packing fraction is multiplied by 10 raised to 4, and therefore we can say that packing fraction F is equal to actual mass minus mass number divided by mass number into 10 raised to 4. This can be also represent as F is equal to M minus A divided by A into 10 raised to 4, where M is a actual mass, capital A is a mass number. The packing fraction means the mass defect per nucleon. Okay, because packing fraction is a ratio of a mass defect and mass number. It is a ratio of a mass defect and a mass number. Okay, packing fraction means a loss or gain of a nucleon. Packing fraction gives the stability of a nucleus. Atomic mass of any nucleus is a measure relative to carbon 6 isotopes, carbon 12 isotopes of carbon, and therefore the packing fraction of carbon is 0. Packing fraction gives the nuclear stability. If the packing fraction is negative. Packing fraction is negative. It indicates that the nucleus is more stable. If a packing fraction is a positive, it indicates that the nucleus is unstable. Okay. Here, packing fraction for carbon is 0. There is a separate branch for helium, carbon and oxygen. It indicates that the packing fraction of this element is very small. Okay. Here we can say that if a packing fraction is a negative, then the elements are more stable, and therefore iron is more stable, because atomic mass of iron is 56 and the packing fraction is a positive. Okay. For the lighter element, okay, such as helium, this element having a positive packing fraction, and therefore we can say that these lighter elements are unstable. While if we consider the atomic mass is greater than 200, then the packing fraction is increases with increasing mass number. It became positive, and therefore the heavier nuclei which have mass number greater than 200 are unstable. So we can say that the uranium having unstable nuclei, and therefore the uranium is break into the fission fragment. Uranium is a break into the fission fragment. The fission process is carried out in heavier nuclei. While in case of the helium, that is it is a lighter nuclei. The lighter nuclei are also unstable, and therefore the lighter nuclei are fused together. Okay? Because the packing fraction is a positive for lighter nuclei, and it is also positive for the heavier nuclei. For we can say that for the iron, the packing fraction is a negative, and therefore it is a more stable. Packing fraction may be negative or positive. If a packing fraction is a negative, we can say that the actual mass of a nucleus is less than the mass number, because we know that the packing fraction is actual mass minus mass number divided by mass number. So that actual mass is less than the mass number, and therefore the packing fraction is negative. In such case, there is some mass get transfer into energy due to the mass defect during the formation of a nucleus, and therefore such nuclei are stable nuclei. Okay. The packing fraction is negative. It indicates that the nuclei are more stable. If packing fraction is a positive, it indicates that the actual mass of a nucleon is greater than the mass number, and therefore the nucleus is unstable. In this case, the nucleus is unstable. Packing fraction is a positive, then the nucleus is unstable, or it gives it have the tendency toward the instability. Okay. However, this is not quite correct for the element of low atomic mass. The Aston plotted the observed packing fraction against mass number. The curve is known as a packing fraction. It is seen that for helium, carbon and oxygen, atom has number multiple of a 4 do not lie on a curve, but they have separate branch. So in the packing fraction curve, we see that the carbon, helium and the oxygen have a separate branch. Okay, the packing fraction of a carbon is a 0. Um, these nuclei are stable because their packing fractions have a very small value. Uh, the transition element with mass number in the neighborhood of A is equal to 45 have lowest packing fraction with negative sign, which gives their high stability. Okay. Beyond mass number 200, packing fraction became positive. Okay. And increase with increase in mass number. If mass number is increases, then the packing fraction is a positive and it's also increases. This indicates that nuclei have mass number greater than 200 are unstable. Nuclei beyond the mass number 230 are radioactive and they are disintegrate spontaneously. So the element which have mass number greater than 230, uranium 238 is of course radioactive element which emits alpha, beta and gamma radiations. So in this lecture we discuss packing fraction. Packing fraction is a ratio of mass defect and mass number. Okay. Packing fraction is a very small quantity and therefore it is expressed as we can multiply 10 raised to 4 to this very small value. Okay. So it is expressed a part of 10 raised to 4. Packing fraction may be positive, negative or 0. We can represent the atomic mass of all element by using carbon 12 isotopes and therefore the packing fraction of a carbon is 0. There is a different branch for helium, carbon and oxygen because these have very small packing fraction. If packing fraction is a negative, then it indicates that it have the atom have stable nuclei. If a packing fraction is a negative, it indicates that the atom have stable nuclei. If a packing fraction is a positive, it indicates that the atom have unstable nuclei. And therefore, for the lighter nuclei, packing fraction is a positive. Okay, packing fraction is a positive. If we consider the case of the iron, then the packing fraction of iron is a negative. It indicates that the iron is more stable. So the mass number is in between 45 to 200 having packing fraction negative. Okay. Therefore, it has stable nuclei. But when the atomic mass is increases beyond 200, okay, then the packing fraction is increases with the mass number and it became positive, and therefore beyond 200 or 230, the elements have unstable nuclei, and beyond mass number 230, the elements are radioactive elements, and these elements emits alpha, beta, and gamma radiation due to the unstable. In next lecture, we have to see what is a nuclear stability.